We want to solve the absolute value equation 5 plus 2/3 times the absolute value of the quantity 3x plus 4/5 equals 15. To begin, we need to isolate the absolute value. For the first step, we subtract 5 on both sides. Simplifying, we now have 2/3 times the absolute value of the quantity 3x plus 4/5 equals 15 minus 5, which is 10. Next, the 2/3 is attached to the absolute value by multiplication, so we're probably thinking we should divide both sides by 2/3, which is correct, but instead of dividing by 2/3, we will multiply by the reciprocal of 3/2. And let's write 10 as a fraction with the denominator of 1. On the left, 3/2 times 2/3 equals 1. We now have the absolute value of the quantity 3x plus 4/5 equals on the right. Let's simplify before multiplying. There's 1, 2, and 2, and 5 2s and 10. We're left with 5 times 3, which is 15. And now from here, because the absolute value of positive 15 equals 15, and the absolute value of negative 15 equals 15, we need to set up and solve two equations, where one equation is 3x plus 4/5 equals positive 15, and the second equation is 3x plus 4/5 equals negative 15. For the equation on the left, for the first step, we subtract 4/5 on both sides. Simplifying, we have 3x equals 15 minus 4/5. To perform the subtraction, we need a common denominator, which is going to be 5. This indicates we multiply 15 divided by 1 by 5/5. We have a common denominator of 5, and the numerator is 75 minus 4, which is 71. So now we have 3x equals 71 divided by 5. And now to solve for x, we might be thinking we should divide both sides by 3, which again is correct, but because we have a fraction on the right, we will multiply by 1/3 instead. Simplifying, 1/3 times 3 is equal to 1. 1 times x is x. We have x equals, on the right, 71/15. And now for the second equation, again, the first step is to subtract 4/5 on both sides. Simplifying, we now have 3x equals negative 15 minus 4/5. Again, we multiply negative 15 by 5/5 to obtain a common denominator. Notice now the numerator is negative 75 minus 4, which is negative 79. We have 3x equals negative 79/5. And now again, to solve for x, we multiply both sides by 1/3. And again, simplifying, 1/3 times 3 is equal to 1. 1 times x is x. We have x equals negative 79/15. So we have two solutions to the absolute value equation. Before we go, let's verify these solutions are correct. One way to do this would be to perform substitution with both of these x values back into the original equation to make sure they actually satisfy the equation. The other method is to check the solution graphically by graphing y equals the left side of the equation, which is 5 plus 2/3 times the absolute value of the quantity 3x plus 4/5. And then also graph y equals the right side of the equation, or y equals 15, and then look for the x coordinates of the points of intersection. Let's do this using decimals. I've already set this up. I have the two equations on the left, one in green and one in black. I also entered these solutions so that we could get the decimal approximations, because the exact values will not show on the points of intersection. And now we click on the points of intersection, and notice the x values of the 2 points of intersection do verify our solutions are correct. I hope you found this helpful.